Okay, for this next exploration, what I'd like you to have is make sure you have the grid on the background and you have your axes shown like this. And then take your line, put one of the points on the y-axis, so it's locked to the y-axis, and the other one just put out in the middle here somewhere, so it can be moved freely. Notice it's listed as a free object. That's B, that's this one. And this one is listed as a dependent object because it's tied to some other thing. In this case, it's tied to the y-axis. Okay. What I'd like you to do for this exploration is to take the equation of the line and put it into a different form. If I right-click on it, I can bring up this menu, and this says equation y equals mx plus b. And that changed it around. So instead of having something x plus something y equals a constant, it has the y on the left by itself, and just some number times x plus some number over here. This is called the slope-intercept form. It's called the y equals mx plus b form. If you've gone through Algebra 1 far enough to get into graphing, you're probably familiar with y equals mx plus b. Okay. What I'd like to show you right now is the connection between these two forms of the equation. This one is something x plus something y equals something. Frequently it's referred to as ax plus by equals c. And let's make the equation a little simpler here. Let's put that on the 2, and let's put that there. Okay, so now what we have is minus 3x plus 2y equals 4. Alright, so let's go over and I'm going to copy that down, and let's go over and see how we can turn this equation around and come up with the equation in y equals mx plus b form. So it says y equals 1.5x plus 2. Those two equations are completely equivalent. It's just the patterns we see in this form are going to be different. Okay, here I've written down the same equation we were working with a minute ago. This is what they called ax plus by equals c kind of a form. In other words, some number times x, in this case a would be negative 3. Some number times y, in this case b would be 2, and the constant is 4. Let's convert this into an equation of the form y equals something x plus something. That's the goal. Well, what you want to do is you want to keep the y term separate from the others. So let's start by getting rid of this term. So add 3x to both sides. So plus 3x plus 3x. So 2y is equal to 4 plus 3x. Now I'm going to interchange these two terms just so it'll match the form we're going to get from GeoGebra. So 2y equals 3x plus 4. Okay. Now I divide by 2 because I want to simply get y. So if I divide by 2, I'm going to get y equals 3 halves, or 1.5x, and 4 divided by 2 is 2. So this equation is completely equivalent to this equation, except I've solved it for y. Okay, so here it is. Y equals 1.5x plus 2. So the goal is, if you know the number in front of the x and you know the constant, you can predict what the line over here is going to look like. So for instance, if I were to put this point on the 3, does it have something to do with that? If I put it on the 1, what happens if I put the b any particular place? What's changing when I change b? And how is it changing?